In this video, we are going to make a simplified sketch of one of the atrioventricular valves in cross-section. To make it easier on myself, I'm going to start with the atrioventricular valve that is on the left side of the heart, called the bicuspid valve. Remember, bi means two, and cusps are those flaps. So it will be easier for me to draw the valve that has two flaps than it would be if I wanted to draw the tricuspid valve, and I would have to show three flaps, which is much more difficult in cross-section. So since I am only looking at the left side of the heart, I won't need to draw both atria and both ventricles. Instead, I can just show one. I'm going to draw in the two cusps with a very small opening towards the middle. The top chamber that I am showing is going to be the left atrium because we are on the left side of the heart. The bottom chamber is going to be the left ventricle. And just a reminder, after leaving the left ventricle, blood is pumped through the systemic circuit to the capillaries of the body, not to the lungs. With the sketch I have now, it looks as though the cusps are just free-floating in space between the atrium and ventricle. However, these cusps are being anchored by small muscles called papillary muscles. They protrude from the sides of the ventricles. Notice that these small muscles do not attach to the cusps directly. Instead, they are attached with small fibrous strands. These fibrous strands are called chordae tendineae. If you've ever heard the expression, pulling at your heartstrings, well, here are your heartstrings. They connect the papillary muscle to the cusps of the atrioventricular valves. Let's now imagine what might happen if these papillary muscles were to contract. To show this, I'm going to redraw my sketch, still only having two chambers of the heart being shown. I'm going to draw in my papillary muscles, but I'm going to make them shorter to show that they have contracted. The chordae tendineae are still about the same size as they were in my previous sketch. But because they cannot stretch and the papillary muscles have contracted, those cusps of my bicuspid valve are now getting pulled downward. As a result, the atrioventricular valve is now open. This allows blood to flow from the atrium to the ventricle. So the contraction of papillary muscles results in opened atrioventricular valves. And in this case, with the bicuspid valve, blood will now be able to move from the left atrium into the left ventricle. When the papillary muscles relax again, the two cusps of the bicuspid valve will return to their original position. This will close the valve. It is important for the atrioventricular valves to be closed when the ventricles are pushing blood out to the body. This prevents blood flowing backwards and ensures that we have unidirectional blood flow through our circulatory system.